All right, so hopefully you've had a chance to give this one a try. Again, we just want to find the solution set for this system of linear inequalities, of inequalities, right? We want to find the x and y points that satisfy all of these inequalities. All right, so we just need to graph each one by one, and then evaluate some test points and figure out which portion of the plane satisfies all of these inequalities. All right, so these first two inequalities, x is greater than 0 and y is greater than 0. So where is x greater than 0? All right, so here's the x-axis. So x is greater than 0 on this half of the plane. So x is greater than 0. I'm just going to draw some little arrows, actually. Maybe I'll draw them in green, just since my axes are in green. All right, so x is greater than 0 in this half plane, right? Basically the right side of the y-axis. Okay, so that represents anywhere, and I could shade all of this, but I don't really want to do the shading right now because it just makes it messy. Okay, so I'm going to put these little arrows here to indicate that, okay, I want values that are on the right side of the x-axis, or the y-axis, sorry. And then, okay, the next inequality is y is greater than 0. Okay, so y is greater than 0 anywhere above the x-axis, right? So I can just draw some arrows, okay? So really I'm just interested in the first quadrant here. That's basically what that's saying. All right, let's take a look at the next inequality. I've got x plus y minus 6 is less than or equal to 0. Now that's, the equality is a line, right? So I can graph the line where x plus y minus 6 is equal to 0. So let's do that, because that's what's going to divide our Cartesian coordinate plane into two parts. And so again, I can just find the x and y intercepts. So to find the y-intercept, x is equal to 0, and you get y minus 6 equals 0, so then y is 6. So this line passes through the point 0, 6. I can also find the x-intercept by letting y equal 0. When y is equal to 0, I get x minus 6 is equal to 0. And so then x is equal to 6. So I can graph those 2 points. All right, maybe I should graph this. Maybe I should use a different color here. Let's use red. All right, so I'm going to just kind of draw over this with red just to indicate it. This is the, I'm graphing this equation. All right, and so I need, we have an x-intercept and a y-intercept are both 6. So it looks like that's 6, right? This is the point 6, or 0, 6, I could call it, right? If I count over 6 here, it looks like this is 6. Is that right? Yeah, that looks like 6. Okay, so this is 6, 0. All right, so I'm just going to connect those 2 points in, with a line. All right. Now I could keep going with the line in the opposite directions if I want to, but I already know that I really only care about the points in the first quadrant, so I don't have to draw the line out into the other quadrants. All right, so we got the first line graphed. So let's take a look at this next inequality. 2x plus y minus 8 is less than 0. All right, so first I'm going to graph the line where 2x plus y minus 8 is equal to 0. So I'm going to, again, just find a couple of points, and oftentimes the x and y intercepts are the easiest. So I put in x equals 0, I get y equals 8. If I put in y equals 0, all right, y is equal to 0, you get 2x minus 8 equals 0, so x has to be equal to 4. All right, so now I'm going to graph those 2 points. So 0, 8 is going to be right here, and 4, 0 is right here. Okay, so I'm just going to connect those with a line. Okay, if I can draw a decent line. Okay, so there's my line that represents all the points where 2x plus y minus 8 is equal to 0. All right. So now I just need to figure out which side of the line is represented by the inequality, right? Which side of the line contains the points that satisfy the inequality. All right, so let's test some points. I'm just going to test some points just like I did before. So let's do, test points. All right, now it looks like 0, 0 is available. So let's just test 0, 0 and see if that is a point that satisfies each of these inequalities. So I'm going to take the first inequality, x plus y. So 0 plus 0 minus 6 is less than or equal to 0. And I just want to ask myself, is that true? And that is true, right? Because the left-hand side just calculates out to minus 6, and minus 6 is less than 0. So this is true. This checks out. So I know that 0, 0 is on the correct side of the line that contains the points that satisfy the inequality. So I'm just going to put some arrows on my line to indicate which side of the line I would shade if I were going to shade it. All right. I'm not going to shade it because it just gets messy. These arrows make it messy enough. All right, let's test the other equation. 2x plus y minus 8 is less than or equal to 0. And I'm going to just use this 0.00 again because it's available. So I get 2 times 0 plus 0 minus 8 is less than or equal to 0. Is that true? Well, over here, this calculates out to minus 8. Minus 8 is definitely less than 0. So that's also true. So as it turns out, that 0.00 satisfies both of these inequalities. So I'm going to put arrows on here, right, to indicate which side of the line. And I want to shade the region that contains the points that satisfy all of these inequalities, every single one of them. All right, I want them all to be satisfied. So I just need to look at where all these arrows are pointing, right? I'm putting to the right of the y-axis. I'm above the x-axis. I'm below the red line, and I'm also, kind of below or to the left of the blue line as well. So what I want to do is shade this area here, because that contains all of the points that satisfy all of the equation, all of those inequalities. Right? If I pick a point anywhere else, some places, this satisfies, a point here would satisfy x is greater than 0, y is greater than 0, but it doesn't satisfy either one of the other inequalities. If I pick a point like in here, it satisfies the first, this x plus y minus 6 is less than 0, but it doesn't satisfy the other inequality, that 2x plus y is 2x plus y minus 8 is less than 0. Okay, so I want the region that satisfies all of those inequalities, and it's basically the region that all of my arrows are pointing to. Okay, so that's why I'm drawing the arrows, just because I want to look for the region now that where that my arrows are pointing to. Okay, and that's the solution. That's basically it. It's this solution right here. Now, this brings us to the next topic, which is on bounded and unbounded regions. Now, you can see that this region is, you would consider that to be bounded, because I could draw a circle around that region, and it would be all contained in the circle, right? This one is unbounded because it goes off and infinitely. I couldn't actually draw a circle around it, so. And contain the whole region. So this one would be considered unbounded. All right, I'll talk more about that in the next video, so I'll meet you there.